My name is Edwin Lopez, and this is my final project for physics. First off, I'm going to talk about the first problem, who's who in electricity. I'm going to talk about Luigi. I'm sorry. I'm talking about Luigi Galvini. Luigi Galvini was a scientist. He was born in Bologna, Italy, on September 9 of 1737. He was a father, acquired a degree in medicine, and also went to the Bologna Medical School. When he took a job in comparative amygdalist and gained fame and research on the generality of trace of birds. In 1762, he became a lecturer in autonomy in University of Bologna. A random experiment on November 6 of 1787, he discovered that frog muscles, if traveled by current with two pieces of metal, maybe copper or iron, put into it, the electricity would shock the muscles in it and cause some sort of muscle spasm. And the instrument for the frog, which was attached to an electric rod, which was put into the actual nerve system of the frog, would make it just jump or extend the leg in a way. The first publication of it was in 1762. It was a disruption in structure, function, and pathology of bones. They thought it was the bones being touched by the rods that would make it spaz up. After receiving the degree in medicine and philosophy on July 15, 1959, Galvini divided the first year of the professional career and between medical and surgical practice and research and lecturing on medicine, demonstrating that we know electricity based on nerve impulse. After he did that, he caused a contraction on the actual touching of the nerve, in which also made it made the frog leg expand depending on how many volts. He was a father of two. He was married, and he was a very successful scientist. Next, I'm going to move on to the moon games. The moon game question is, during our moon game project, we studied the Newton's three laws of motion and how they became into play, and the moon's surface as well. Explain the three Newton's laws, given an explanation, and describe the atmosphere of the moon and the earth. So the moon gravity is 1,622 meters per second squared, and also we have on Earth, which is 9.78 meters per second squared. Now, the only difference between the two is that since there's less density in gravity on the moon, you're able to maybe jump higher, move things that are supposedly really heavy, but on the moon they're not. The first law describes that every object has a state of motion, tends to remain in a state of motion, and unless an external force is applied to it. The second law, a relationship between the object's mass, acceleration, and vector. In this law is a direction of force in the vector in the same direction of the acceleration vector. The third law, every action is equal to an opposite reaction. So let's say we're talking about maybe a hammer or a leaf on the moon. Which one do you think would fall, faster? Well, the answer is neither. They both fall at the same time, because on the moon they have the same weight, they have the same mass, or density, you could say. But on Earth, obviously the hammer would fall a lot faster than the actual leaf or feather. And that's because of the density and of the gravity and the mass of the actual object. And the three laws that come in action, let's say that we were supposed to, let's say we hit something in the moon. It just float and slowly come down, depending on how hard you hit it. So let's say you're on your back, you put a rock in between your feet and you kick it up in the air. It's most likely that it will go out of the atmosphere, more likely than it will coming back. Now, we're talking about question 3. Question 3 is on your marks. On your marks, we're talking about a graph, a position and time graph. The seconds are from 0, 4, 8, 12, and 16, position 0, 2, 4, 6, 8. On this graph, you start off going from 0 to 4 seconds in 0 to 8 meters in 4 seconds. So let's say we have my friend Junior. Junior, he's running. He runs for 4 seconds, reaches 8 meters. Then from 4 meters to 6, 4 seconds to 6 seconds, he stops. He stops running at 8 meters. Then, from 6 to 8, he starts running back. At the same speed, just running back from where he was coming. At 8 meters, at 8 seconds to 10 seconds, he stops running again. But this time, he's at 4 meters. He stops running. Once he reaches to 10 meters all the way to 14 meters, he goes up all the way up to 8 meters again in those 4 seconds. Next, from 14 to 16 seconds, there's a big increase in velocity, maybe a 2.5 velocity change, but going in the opposite direction, which makes him go all the way to where he's starting. And the total displacement would just make it, since he's going up forward 8, he stops, he goes back 4, that's 12. 12 and 4 more again is 16, and then 8 and 16 is 24. So from that, you can see that he just started where back he came from. Now to my final answer to the question of Pathfinder. Now we have case A and case B. Case A is velocity 1, a tennis ball going 10 meters per second hitting a wall. Next, it hits the wall and comes back at the final velocity, which is 5 meters per second. We do know that the initial velocity is 10 meters per second. We know that the final velocity is 5 meters per second. We know the mass is 1, and that the time that it took was 10 seconds. So we have to find the impulse, change of momentum, change of velocity, and acceleration. So for this, I wanted to find the change of momentum first. The equation for change in momentum would be mass times velocity 2 minus mass times velocity 1 equals change of momentum. The change of the momentum, which would help me get in the change of velocity, because change of velocity is change of velocity divided by t, which would also give you acceleration. And if on the impulse, that'd be just force times meters, which the force would most likely be just 1. And the direction it's going is -5, but the impulse would be a +5 because it's going, the change in it is 5. That's how much force was given to it to go back. Now in case 2, the speed is actually a little bit higher. The initial velocity is 30 meters per second, and the final velocity is 28 meters per second. So VI equals 30, VF equals 28, T equals 5, which is 5 seconds, and then M equals 1, which is the mass. So we have to find the same principles again. Pulse, change of velocity, change of momentum, and acceleration. To find acceleration, you need change of velocity divided by T. To get the change of velocity, you do VF minus VI, which would give you a -2. A negative 2 would be the change of velocity. And then for acceleration, you do -2 divided by the 5, which would give you a 0.4. The change of momentum would be mass times the initial, which would be 30, minus 1 times 28, which would give you a 2. Impulse would be just force times mass, which would give you the +2 as the impulse. And that is my project. Thank you.